on Voronoi diagrams, which is the geometric representation of where things are in space. So this particular one is looking at cell phone towers. Okay, so we've got 3 towers, 1, 2, and 3, and it's showing him who is inside the shaded region will receive the strongest signal from T4. Okay, so tower 4, we're told, is somewhere in this shaded section. Okay, so it's somewhere in here. Not sure where yet, but it's somewhere in there. So the reason is because any of the points inside this shaded section is going to be closest to tower 4. Okay, so that's the kind of purpose of the Voronoi diagram. So every point in the shaded region is closer to T4 as a cell tower. And then part B, you're told that the second tower has the coordinate -9, 5. So -9, 5. And we're then asked to work out the coordinates of the T4 tower. So whenever you're asked these kind of questions, you will usually have either a horizontal or a vertical line somewhere in your Voronoi diagram. And that's the easiest one to go from. This one is a horizontal, so that means it's going to be a direct reflection, and that will tell you where T4 is. Okay, so if this is x coordinate -9, then that means that the x coordinate of T4 will also be -9 because it has this reflection. Okay, so it's definitely going to be -9. And we also know that this equation is y equals 3. So this is 3. Now, if this is a y coordinate of 5 and this is 3, that tells us that these are 2 apart, which is the same here. So they're also going to be 2 apart. So T4 must sit here at 1. So -9, 1 will be T4. Okay, so that's how we've worked that one out. And then tower T1 has coordinates 13, 3. And we're asked to find the gradient between T1 and T2, which is the gradient of this line here. So we know that it's a perpendicular bisector. So the first thing we need to do is find the gradient of the line between T1 and T2, and then we can use the reciprocal, okay, or the negative reciprocal for the perpendicular. So the gradient is change in y, or rise, over change in x, or run. And that's actually given to you in the formula book as well. Okay, so the gradient is change in y over change in x. So between T1 and T2, we can see there that the change in the y is jumping up by 2. And the change in the x is moving across from -13, I think that's a minus, sorry, -13 to -9. Okay, so -13 to -9 is going to be 4. So the gradient is 2 over 4, which we know is 1/2. Okay, and therefore the gradient of the Voronoi diagram, which is perpendicular, is the negative reciprocal, so -2. So the gradient here is -2.